Okay, so we have a function and it's composed with another function, and we want to find the derivative with respect to x of this composition. How do we go about doing that? We pretend that we don't know the chain rule yet. What we're going to do is we're going to discover the chain rule on our own. Well, you might start with the definition of the derivative, the limit as h goes to 0 of f of g of x plus h minus f of g of x all over, hi Chewy, all over h. So this isn't very useful to us because that's just this, and it doesn't really, you can't really figure that out. What we can do though is we can multiply by something. We can multiply by g of x plus h minus g of x over itself. And then we can just swap the bottoms like this. And then we're going to have, since properties of limits, we could just take the limit of both products. And then, since we swap the bottom, we'll get g of x plus h minus g of x over h. Okay, so now that we've done that, what can we do here? So why did we do this in the first place? So what we did is we manipulated it so that we pulled out a g prime term. This is going to be the derivative of g of x. That's what we wanted. We wanted to remove something so that we could take this. And what we're going to do is we're going to let some variable k equal g of x plus h minus g of x. And you notice that as h goes to 0, it just becomes g of x minus g of x, which is 0. So as h goes to 0, k will go to 0. And we could write it as the limit as k goes to 0. And also, you could rewrite this as g of x plus h equals k plus g of x. So we could replace g of x plus h with just k plus g of x. And then we could take the derivative, or it is the derivative, but the limit as k goes to 0 of f of k plus g of x minus f of g of x divided by k, and you just get the derivative of this with respect to g of x. If that's kind of wacky, but it works. You get f of g of x plus k minus f of g of x all over k. And then we're just gonna multiply by dx g of x. So this, if you look at it, you just imagine that our x is our g of x. So we're differentiating with respect to the function g of x, which is really crazy and strange, but it works. And then this will just be d with respect to g of x of f of g of x multiplied by the derivative with respect to x of g of x. And that's how we get our chain rule. That's equal to this. My marker's dying.